This is number 6 and 7, where we're determining whether the polygons are similar. So what we're looking at here is, if I see the side length here, it's a side length of 1, and this has a side length of 2, this has a side length of 2, and a side length of 4. These side lengths have doubled. Also notice that these are perpendicular lines, so these figures are similar by SAS because these sides are proportional to these sides, and then the angles in between them are going to be congruent. So they are similar by SAS. So we say SAS similarity, so they are similar. Now let's support it by a transformation. If you multiply these by 2, then you can actually multiply by 2 and then translate it. So multiply by 2 and then translate it, and you can go ahead and do that to figure out how many units. Number 7. Here we have our two figures, and what we're looking at is we're trying to decide if they are similar. So we want to look at the side lengths here that would correspond. Now what I see here, and I'm double check my graphing here, that's 1, 3, and then negative 1, 4, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so what I see right off the bat is that this is not parallel to this. So I'm thinking these are probably not similar. If they were similar, usually they go in the same direction and in the same amount so that we can see a triangle within a triangle. The only way this could be similar is if we have some kind of reflected side length going on. So if we look here, this is up 1 unit over 2. So let's look at what BC's length is going to be. If it's up 1 over 2, so that would be 1 squared plus 2 squared is going to equal C squared, our side here. So that's 1 plus 4, which is 5, equals C squared. So then C is going to be square root of 5. That tells me this right here is square root of 5. Now let's see how that compares to up here. Up here we have up 1 and then over 1, 2, 3, 4, 5. So for ZY, that's going to be 1 squared plus 5 squared equals C squared. And that's going to be 1 plus 25, which would be 26, equals C squared. So then C is going to equal square root of 26. So this is square root of 26. And now we need to look at one other set of sides. For example, let's go ahead and take this side right here. So I see I'm going over 1 up 3. So let's look at AB. I've got 1 squared plus 3 squared is equal to C squared. So that's 1 plus 9 is 10. So equals C squared. So C is equal to the square root of 10. So that's this one. Now let's look at this one here. So we've got AZ, and now that means that we're going to go over 2. So that's 2 squared, and then up 1, 2, 3, 4, 5, 6, 7, 8. So plus 8 squared equals C squared. So then that's going to be 4 plus 64, which is 68, equals C squared. And so let's go ahead and reduce the square root of 68. So when we take the square root of both sides, C is going to equal 2 square root of 17. Now let's go ahead and start lining our parts up here. So if this was truly similar, then AB, which we found to be square root of 10, over the side length that goes with it, which would be AZ, 2 square root of 17, would be the same as, let's look at BC, this side here, square root of 5, over, now let's look at its corresponding side, which would be square root of 26. So let's cross multiply and see what we got. When we do 2 square root of 17 times the square root of 5, we're going to get 2 square root of 85. And then let's do square root of 10 times the square root of 26, and that's going to give me 2 square root of 65. Those do not equal each other. All that work to show that these were not similar. So my answer, not similar.